हेलो, जेई एडवांस 2026 में पूछे गए रोटेशनल मोशन के इस क्वेश्चन को देखिए। इस क्वेश्चन को देखकर एक स्टूडेंट ने बहुत ही इनोसेंट लुकिंग डाउट पूछा, जो आप में से कई स्टूडेंट्स के माइंड में एक्चुअली हो सकता है। जस्ट फॉर ए रेफरेंस, ये क्वेश्चन पास्ट में आईआईटी जेई में पूछे गए एक प्रॉब्लम पे बेस्ड है, ऑलमोस्ट सिमिलर है, और उस प्रॉब्लम को हमने इसी यूट्यूब चैनल पे एक महीने पहले पोस्ट किया था। बट लेट अस कम बैक टू द डाउट दैट दिस पर्टिकुलर स्टूडेंट आस्क्ड मी. The doubt in the mind of the student is very straightforward. Why will the cylinder rotate about this point? Why will not it just fly off the edge? ये सिलेंडर ऐसे, इसके पास स्पीड है। वो जो पुराना आईआईटी जेई का क्वेश्चन था उसमें सिलेंडर के पास स्पीड नहीं थी, यहाँ से रख के उसको धीरे से पुश कर दिया था। Now it is moving at a finite speed. So if a cylinder comes rolling on this to this edge, it should simply fly off. Why it will roll? Is there some attractive force which will keep it pivoted to this point? Why? Why won't it just fly off? That is the question. And today we will try to answer this question. The answer is not at all very difficult, but you need to understand a couple of things. First, just before this cylinder reaches this edge, just before it reaches this edge, it is almost at the edge, but not at the edge, right? Just before the cylinder reaches the edge, this point of the cylinder, let us say, is in contact with this point. I should be drawing a cylinder here. Okay, let me draw again. This is the situation. Cylinder is just before the edge. If it is just before the edge, it simply means it is staying on this horizontal surface. So the center of the cylinder is at a fixed height r from this table, and therefore normal reaction and mg must balance out because there is no vertical movement of the center of mass. The cylinder is on the table means the center of mass has a fixed distance from the table. It is at a distance r. So n must always be equal to mg. Now it is off the edge. Let us say it is just on the edge, just before the edge, and a microsecond later, when the so-called rotation starts, the so-called rotation in the question starts. Now, just a microsecond later, this cylinder is okay. It will appear like this only, because within infinitesimal time change, it cannot go anywhere else. It will remain there only. But it has just moved slightly. Slightly means whatever you are thinking, less than that. So, microsecond after this instant, what is happening? Now, according to the question, if we believe it, the cylinder is rotating about this point. Shall I name this point as A? Okay, A. It is rotating about this point A. What does it mean? It means the center of mass of the cylinder is now rotating in a circle of radius r. It has just started rotating in a circle of radius r. Just before this, center of mass is simply moving horizontally. A microsecond later, the center of mass is now rotating on a circle of radius r, which is centered at this point. The speed of the center of mass is still this v only. It is v. But now you have to think that it has started rotating in a circle of radius r. So if I think like that, then the normal reaction has suddenly dropped. Normal reaction will suddenly decrease, because if you assume that this center of mass is rotating in a circle of radius r, then there must be an acceleration in this direction. So mg force will suddenly become greater than normal reaction. Mg cannot change, right? So normal reaction decreases than its earlier value. The equation that you write is mg minus n is mv square by r. I'm just talking about two instances. A split second ago, the velocity was horizontal. Just the very next moment, velocity is still horizontal. But now we cannot say that center of mass is traveling horizontally. Now we will have to say that center of mass is going in this circular path with center at O. So if that is the case, then normal reaction suddenly drops to this value. So normal reaction was earlier equal to mg, and then there is a sudden change in value of normal reaction. Just digressing a bit, in reality, no object is a solid, rigid object, right? So in reality, there is a bit of exaggeration. In fact, a lot of exaggeration. A ball or a cylinder that is rolling, or if it is even standing on a horizontal surface, it will have multiple contact points. Because it is not a perfect rigid body, this normal force and the weight force together deform the object. So because of this deformation, there are multiple contact points. Now all of a sudden, if normal reaction is made to change, as it has happened here, suddenly the normal reaction has changed. So it means that deforming forces have changed, which means it will cause change in shape of the body. Of course, it may not be noticeable to our bare eyes, but yes, it will happen. There will be some change in the shape of the body. And, well, it can cause some energy changes as well. But okay, our body is a perfect rigid body. Forget about those things. So normal reaction has suddenly changed. Now what happens? This center of mass is ready to, in fact, it is already moving on this circular track. A little bit later on, a slightly, think of a time which is delta t ahead. What will happen now? Time delta t later from this instant. Just for sake of ease of drawing the diagram, I will just draw this diameter, okay? So this diameter is right now like this, AB. Slightly later on, it will become like this. This angle is extremely small, delta theta, but whatever it is, it is. So now the center of mass is going in a circle like this, and the cylinder has pivoted around this point. That means you can assume that it has got stuck to this point. Now the forces acting on this object are its weight, the normal force, right? And then there is a friction. Friction, 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 friction. It is friction that will prevent slipping. Now, I have drawn a line like this. What does it mean? What is the direction of friction? So, again, being a bit practical, the edge, the table edge that you are seeing, what is that edge? Actually, table edge is like this if you magnify it. This radius of curvature of the edge is very small compared to radius of this cylinder. This is what we are saying. If it is a sharp edge, means this round thing has a very small radius of curvature compared to this. So the normal force obviously has to be perpendicular to the surface of the cylinder, which is this direction only. And the other component of contact force, the tangential component, it is termed as friction. So the friction force applied by the table edge on the cylinder is somewhat like this. But okay, that was not the doubt. The doubt is, why won't it fly away? I'm coming back to that doubt. Now, think of a particle, just think of a particle, which has been projected with speed v horizontally. It will move on a parabolic path, all of us know that. What is radius of curvature of the path at this point? Radius of curvature, it means, for a moment if we assume, in fact we will have to assume, that this parabolic path is made up of pieces of many circular paths. So small portion of a parabola out here is basically part of a circle. And radius of this circle is the radius of curvature at this point. So what we are assuming? We are assuming that this particle is moving on yellow colored circle for a moment. For an instant, the parabolic path, the section of the parabolic path, and this small section of the circle, they are befitting, they are fitting on each other. So particle can be thought to be moving on this yellow colored circle, right? What is force acting on the particle? The force acting on the particle is mg only. And if you think that it is moving on a circular path, then mg has to be equal to mv square by r, which means radius of curvature is v square by g, isn't it? Rather, let me write it like this: v is equal to under root rg. If the particle is moving on a path that has radius of curvature r, then its speed must be equal to under root rg. Now suppose you throw the particle with a lesser speed, what will happen? If you throw the particle with a lesser speed, what will happen? The force remains same, but the speed is small. The momentum is less, but the force remains same. So the same force with less momentum, the force will be able to sharply deflect the particle. It will be able to quickly change the direction of momentum. And what will happen is, it will result in a path that has lesser radius of curvature. अगर आप कम स्पीड से फेंकेंगे तो the path will have a lesser radius of curvature, less than this. And if you project it with higher speed, then the path will have higher radius of curvature. Now look at this situation. This center of mass of the cylinder, it is having a speed at the topmost point. I mean, just when it is about to leave the table, or when it is about to rotate about the edge, whatever, at this position. We said that the circular motion of center of mass starts here. Yes, it is going to go in a circle like this. Right now its speed is given. If this speed were exactly equal to under root gr, what will happen? Can you think of? If this speed is exactly equal to under root gr, then this center will move in a circle of radius, r means this r, radius of the cylinder. If this speed were exactly equal to under root gr, then this point, that is center of mass, will go on a path that has radius of curvature that is exactly equal to r. If the speed is greater than this, then this point will move in a circular arc or a path which has radius of curvature greater than r. So if his speed is greater than this, the center of mass will move on a path which is having radius of curvature greater than r. So if center of mass is moving on a path which is having radius of curvature greater than r, it simply means that this contact has been lost. Because if the cylinder remains stuck to this point, then center of mass has to be at a distance r. This distance cannot change, it is a rigid body. But if center of mass is, if you just think for a moment that it is moving in a circular path of radius which is greater than r, it simply implies only one thing, that this contact has been lost. So yes, this cylinder will fly away. It will just go into air if this speed happens to be greater than this. But in the question it has been given that this speed is actually less than this. Therefore, remove the table, forget about table, there is no table, there is no horizontal surface. If you throw this ball with this speed, what will happen? It will try to go on a path that has radius of curvature less than r. So if really this table is removed, then center of mass will move on a path that has radius of curvature less than r. But because this table is present, this cannot happen. the distance of center of mass from this point has to remain r. So obviously, if your speed is less than this, what is going to happen? Center cannot be allowed to move. It cannot be allowed to move in a path that has radius of curvature less than r, right? Because there is a support over here. This point cannot shift this way. So the only thing that can happen is there will be a normal reaction, and this normal reaction actually decreases the component of mg force in this direction. At the topmost, very top, we have already seen that there is a non-zero normal reaction. We calculated it to be mg by 3 or something, I think. I forgot where it is. Yes, if you substitute for V, you will get a value of normal reaction. So there is a non-zero normal reaction out here. That means net force towards the center is less than mg. Okay, that's fine. If the net force towards the center is less than mg, then it is possible to maintain the radius of curvature equal to r at this speed. So naturally, there will be a push from the table, and the contact will remain intact. So contact remains intact if the speed is less than under root gr. Now, according to the question, this becomes a pivot point, and it rotates about this point. Obviously, as it rotates, its center of mass falls, its energy increases, and at some point again, the normal reaction becomes 0. Thereafter, it gets airborne. That is what was explained in my video a month ago. And if some of you are in class 11th or 12th and not very sound in this kind of discussion, you can have a look at that video as well. This problem also has a bit of language problem. That means it could have been written in a better way, but okay, at least personally I am ready to ignore it because whole of country has understood the problem in a particular way, and that is what the writer of the problem intended to say. So let it be like that. But yes, the problem could have been drafted in a much better way. Thank you. Goodbye.